Okay, last lesson for measurement. We're going to deal with the surface area and volume of spheres. So for the volume of a sphere, Gary, a high school student, used the method of displacement to determine the volume of a sphere. He used a cylinder and a sphere ball with the same height and diameter. First, Gary completely filled the cylinder with 375 milliliters of water and placed it on an overflow container. Then he pushed a ball into the cylinder and allowed the water to overflow. Finally, he measured the volume of the water in the overflow container and the volume of water left in the cylinder. He determined after 3 trials that the volume of the water in the overflow container was 250 milliliters and the volume of water in the cylinder was 125 milliliters. Gary concluded the following. The volume of the water in the overflow container is the same as the volume of the ball. The volume of the water in the overflow container is 2/3 what the volume of the cylinder is. The volume of the ball is going to be 2/3 of the volume of the same cylinder. And the volume of water left in the cylinder is 1/3 of the original volume. If we're going to verify Gary's results by conducting their own trials, well, you can go and try it, but it's true, it works. So, first, he considered a sphere and a cylinder both with a radius of 5 centimeters. Mark the radius of the sphere and the cylinder on the diagram and explain why the height of the cylinder is going to be 10 centimeters. Well, if this is the radius of the sphere, then you could start at the center of the sphere and go in any direction, right, left, up, or down. Which means that the height here is just going to be 2 of the radiuses, which is going to make up 10. Gary determined the volume of the sphere to the nearest tenth using the formula for the volume of a cylinder, and he said that the volume of a sphere is going to be 2/3 the volume of a cylinder, or 2/3 pi r squared h, which means that in this case, if h is equal to 2 times 5, or 10, then it's going to be 2/3 pi 5 squared times 10, or he said that this could be the same as 4/3 pi times 5 to the power of 3. Which means that when he was actually solving this one, then he's going to state that this is 523.6 centimeters cubed. If I'm doing it for a general one, if 2/3 times the volume of the cylinder is equal to 2/3 pi r squared h, and h is 2 r's, then I'm going to say that 2/3 times pi times r squared times 2r is going to give me, well, if I have r squared times another r, I have r cubed. I can multiply the 2 into the 4/3, multiply into the numerator, and get 4/3 here, and then I just have the pi in the center, which means that I just call it 4/3 pi r cubed. The formulas for the surface areas, well, the unique thing about a sphere is the surface area is going to make up exactly 4 circles that you'd get if you cut a sphere in half and then took the area of that circle. It's going to be 4 times that going around the outside curved surface of a sphere. The volume, which we just saw, is 4/3 pi r cubed. If I'm dealing with a hemisphere, or cutting a circle and cutting a sphere in half, where the term semicircle is used to describe half circle, hemisphere is used to describe half a sphere. When considering the surface area, you may need to include the circular base on the bottom of a sphere. So, if I took my sphere, I cut it in half, then what happened was I took away 2 of the circles on the outside, or 2 pi r squared, because I took away half of the pi r squareds. But when I cut it in half, suddenly I created this new flat circle, which means I have to add one of them back in. So if I had 4 pi r squareds minus 2 of the pi r squareds, but then adding in a new one that's created, I'm left with 3 pi r squareds. We get that here. The curved surface area is the 2 pi r squareds, and then we're adding in the flat surface area on the base. The volume of this is going to be 1/2 of the volume of my sphere, 4/3 pi r cubed, where I can combine the 1/2 and the 4/3 to get 2/3 pi r cubed. For a hemisphere, if I don't need to include the base, then I just call it 2 pi r squared. I just call it the outside curved surface area.